got it? Okay, so this lesson's on reflections, and it's exactly what it sounds like. A reflection is when you flip a shape over a line or axis. And when a figure has been reflected, it will be a mirror image. Okay, so now we're going to look at coordinate rules. I'm specifically going to focus on the concept here. Here, it's saying we're reflecting point A over the x-axis. So they bolded the x-axis, and that's what we're reflecting the point over. When we reflect it, it needs to be the same exact distance from that line. So point A is 2.2 units above, so then we make A prime just 2 units below, and that's the reflected point. If for whatever reason visually we couldn't do that, and you'll see that in some of our examples, you can use this rule down here. When you reflect over the x-axis, the x stays the same, and then the y turns to the opposite sign. So for example, with our first point A, it was at 2, 2. And then for A prime, our x will stay the same, and then our y will change signs. And if we check those coordinates, 2, -2, yes, that's where our point landed. Okay, the next one, it shows a line of y equals x. So A is going to reflect over the line of y equals x. With this line, it is a diagonal, as you can see, and it has a positive slope, so it's going up and to the right. So A needs to be the same distance on the other side, so we get A prime. So as you can see, this is completely different from the last chapter, and it's a fresh start for everyone. Okay, as far as the coordinates, we have a rule here. When y equals x, literally y equals x over here. So we're taking our original coordinates for A, which is 1, -1. And for A prime, it flips -1, 1. -1, 1, and that is where we plotted our point. Okay, the next one, it's reflected over the line x equals 4. Now for this one, they have the line drawn out, but they won't always have that drawn. To find this line, x equals 4, so 1, 2, 3, 4, here's x equals 4, and then you would just draw a line if you needed to. But reflecting this point over it, just put it the same distance on the other side. And it says no rule because you can't like manipulate the points in any way. You just have to visually find the other side. And the next one, a reflection over the y-axis. So here's our y-axis. It's bolded for us. Reflecting this point over that y-axis, we get A prime. And then as far as the coordinates go, point A is at -1, 3. Then for A prime, the rule is the x changes sign and the y stays the same. So this becomes +1 and y just stays the same. 1, 3. That's where we plotted our point. This one says the line y equals -x. It's similar to the one above it, which was y equals x, but notice the line has a negative slope. The slope is -1. So it's going down into the right, and then our point just gets reflected on the other side. And then as far as the coordinates go, point A is at -2, 0. So A prime, x and y switch places, and it becomes the opposite sign. So here, you get 0, +2. The next example. Now the line that is being reflected over is y equals -3. So they went down to y equals -3, drew the line here. Now reflecting this over, it's 2 units below, so we'll do it 2 units above. And then flipping to the next page. Okay, so this page is all examples. We've already gone over the concepts. Now it's just like, how would they ask this in problems? It says, write the rule for each reflection. So here it shows this triangle reflected here. Where are they reflecting it? They're reflecting it over the x-axis. So reflect over x-axis. And then in terms of the points, you could look over at the other side or just copy this down. It was take the original points and then x stays the same and y turns negative. For the next one, the line of reflection would be this diagonal here. Remember, that's one of the y equals x. So reflect over the line y equals x. I know it's a positive x because, again, we have that positive slope. And then the rule for this one was just flip the point. So xy would then become yx. And C. Just looking at these two, the line of reflection would be right here. And that is at x equals 2. Reflect over x equals 2. Okay. And there was no coordinate rules for that one because that line could be anywhere. Okay, next example says reflect the figure over y equals 1. First of all, we need to find that line, so we just go to y equals 1, which would be right here, and then draw the line. We wouldn't draw it vertical because that's just the y-axis. So draw it horizontal. And then when we reflect the shape, just reflect each point and then you'll get the shape. So I'm just going to focus on each point. Point E will go 1 above, so that's E prime. F is 3 units below that line, so we'll do it 3 units above. And D is 2 below, so I'll make that point 2 above. And then graph the shape and it should come out perfect. And the next one, reflect the figure over the line y equals x. Again, that x is positive, so therefore positive slope, it's going to be the diagonal that goes up to the right like this. I'm going to zoom in on this one here. Okay, this one is a little bit different. Point C, I can see that it would land right here. C prime would be right here. But B and A are a little bit trickier. It's hard to see like where that would actually land. So for this one is a good example of when we need to use those rules. Remember, for y equals x, we take the coordinates and we flip them to yx. So for point B, our original is -2, 1, 2, 3, 4, -2, 4. So our coordinates for B prime would be 4, -2. And we're going to do the same thing for point A. A is at -3, 2. So A prime would be at 2, -3. And then you can connect your dots. And then of course just make sure that that answer is logical. If you made an error, it'll be very obvious. Okay, and then more examples. Now we're just combining everything into one problem. Graph each transformation. It says reflect over x equals -1. So x equals -1 would be right here. And then draw your line of reflection. It's kind of blurry. Okay, and then put your points on the other side. So b prime would be 1 away. A prime would be 2 in this direction. And then connect your points. B, it's asking to reflect over the y-axis. So here's our y-axis. And again, we're just going to reflect each individual point over that line. So M prime, L is 1, 2, 3, 4 units. So 1, 2, 3, 4 units this way. And N is 3 units this way, so we'll do it 3 units this way. N prime. Okay, C is a little bit more challenging. On Khan Academy, there's actually a lesson that says like challenge or like advanced reflections, and this would be an example. It says reflect over y equals 4. So I go up to y equals 4. And I'm going to make a line right here at y equals 4. And I'm reflecting the shape over the line. And you might say it's like on the line, right? It is. We're going to take each point and just reflect it to the other side. So y would go 1 unit this way. So this is y prime. Z, which is 1 unit below, will go 1 unit above. So this is z prime. And then x, which is on the line of reflection, will just stay in the same spot. So x prime will be the exact same location. And then you can connect the dots. So if you just look at it one point at a time, then you can do it. Then it gets easy again with D. Reflect over x equals 3. 1, 2, 3. Draw the line at x equals 3. And then plot each point on the other side. A prime, B prime, D prime, and C prime. For E, it says reflect over y equals -x. With this -x, our line will go diagonal to the right, so it has a negative slope. Then as far as reflecting L over that line, that's pretty easy, but K is a little bit more complicated. So for this one, we're going to use the rules. The rules for the y equals -x was you take your originals and you flip them and change the sign. So it becomes -y, -x. Then taking our point L, which is at -1, 2. And L prime would then become -2, +1. And K is at 1, 2, 3, -4, -3. That becomes +3, +4. K prime. And then you can connect your dots. And last one on the page, reflect over the x-axis. So again, just kind of trace over your x-axis. O and N are going to stay in the same spot, so O prime is just going to be in the same spot, and so is N prime because it's on that axis. Then M is 3 above, so make it 3 below. And L needs to go 3 below as well. L prime. And there's your shape. There's a couple of things I want to go over before you do the homework. A couple of things that are on the homework that weren't here. One is line of symmetry, specifically like how many lines of symmetry a shape has. So for example, a square, which has all the angles the same and all the sides the same length, has 4 lines of symmetry. It has a line of symmetry here, 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 and here. Any regular shape, so for example, a regular pentagon would have 5. So if it's a regular pentagon, it would have 5 lines of symmetry. I'm sure you're noticing a pattern here. It's based on the number of sides. So a decagon with 10 sides would have 10 lines of symmetry if it was a regular shape. Another thing that comes up, and it's just one problem that you might get, is reflection over the origin. If a shape is reflected over the origin, the points go like this. If you had 2 positive points, they would become negative, and that's a reflection over the origin. So if you get that one, that's how that works. Okay, so for the rest of the class, you have to do homework in Khan Academy. The laptops aren't working, so you can use your phones to do it, but actually use your phones to do it.